Semester 2 test review covering modules 6 through 11. Question 1, we're going to simplify exponentials here. So d to the negative 2/5. I can't have negative exponents in my answer, so I need to rewrite this so I don't have negative exponents. So I do the reciprocal, which would be 1 over d to the 2/5. But I can't have fractional exponents in the denominator. So to get rid of it, I'm going to multiply this by a fractional exponent where I just have an integer. So this would be 3/5, because when I multiply like bases, I add the exponents. And when I do that, down here, I'm left with d to the first. But whatever I do in the denominator, I have to do in the numerator. So multiply the top by d to the 3/5 power. And d to the 3/5 times 1 is d to the 3/5. So my final answer would be d to the 3/5 divided by d. This next one, I'm dividing like bases. So when I divide like bases, I subtract the exponents. So my exponents have fractions in it. So the common denominator of 5 and 2 is 10. So 3/5 would be 6/10 minus 1/2, and tenths would be 5/10. So our final answer would be c to the 1/10. Next one, I multiply like bases, I add the exponents. So this would be n to the 10/5. 10/5 is the same as n squared. So my final answer, n squared. And the other rule of exponents, when I raise a power to a power, you multiply the exponents. So this would be m to the 8/15. I cannot reduce that, therefore that would be my simplified answer. Question 2. Write the simplified form. So here I need to rationalize the denominator. So I would have 4 square root of 5 plus 4, and I do that in the numerator and the denominator. Now treat this denominator like a difference of 2 squares. And when you have a difference of 2 squares, the middle terms cancel off. And all you're left is really with a squared minus b squared. This is the same thing as saying a plus b times a minus b. So our a is like 4 square root of 5. So if I take 4 times 4, I'm left with 16. Square root of 5 times square root of 5 is 5. And then I have minus 4 times 4 is 16. And when I simplify this, 16 times 5 is 80. 80 minus 16 is 64. Now in the numerator, I just distribute, and this is going to give us 24 square root of 5, 24x square root of 5 plus 24x. Now that one I can simplify. I can take an 8 out in the numerator. That leaves me with 3x square root of 5 plus 3x. And the denominator I can divide out an 8. And I'm left with a final answer of 3x square root of 5 plus 3x, all divided by 8. Question 3, write the simplified form of the following. Here we're going to break down each radical. This would be the square root of 9 times the square root of 2x, which makes that 3 square root of 2x. This is the square root of 4 times the square root of 7, which will make that 10 square root of 7, because 2 times 5 is 10. Here is the square root of 49 and the square root of 2x. Square root of 49 is 7 times negative 3 is negative 21 square root of 2x. And then the last part, I cannot simplify that, so that stays as 3 square root of 7x. Now I combine like terms. Here I have 3 square root of 7x is by itself, so that doesn't have any partners. And then I have 3 square root of 2x minus 21 square root of 2x equals a negative 18 square root of 2x. And then I'm left with a minus 10 square root of 7. Question 4, we're going to break these down. So I have the 4th root of 4. I cannot break that down. Times the 4th root of x to the 5th. that means I could have the fourth root of x times the fourth root of x times the fourth root of x times the fourth root of x, that's 4, times the fourth root of x. Now if I group 4 of these together, this equals the radicand, which is just x. And then the top part, or the fourth root of y to the 20th, that would be just y to the 5th, because I can take 20 divided by 4 gives you my 5. So our final answer would be y to the 5th times x times the fourth root of 4x. The last one here, we have the square root of 225, which is 15. The square root of x to the 8th is x to the 4th, and the square root of x squared would be, the square root of y squared would be y. Because the index is 2, this exponent on the y is an even, so we have an even, and our answer is an odd. We would have to make sure that this gives us a positive y value, so we would want to make sure that we have an absolute value with our y. Or you could put the whole thing as the absolute value of 15 x to the 4th y, all in the absolute value. Question 5. If f of x equaling 3x, g of x equaling x plus 4, and h of x equaling x squared minus 1, find the value. So here they're saying if you put 1 in for x in g of x, and then whatever answer you get for that, put that in for x in f of x, what would your solution be? So the first thing I'm going to do is put 1 in for x for g of x. So that's going to be 1 plus 4, which is going to give us 5. Now I'm going to put that in for f of x. So this is 3 times 5. So my answer would be 15. Next, we always work from the right to the left, so you're going to put 3 in for x of g. So I'm going to do that first. So g of 3 is going to equal 3 plus 4, which equals 7. Now I'm going to put 7 in for x of f of x. So I have f of 7, which is going to equal 3 times 7, which equals 21. Now they're telling us to put 21 in for x of h of x. So h of 21 is going to equal 21 squared minus 1. So now if I grab my calculator here, we have 21 and we're squaring it, and then we have minus 1. That's going to give us 440. So our answer for this one would give us 440. Question 6, use these two functions to find the following. Here we're adding the functions, so here we're just going to be adding like terms. So f of x is 2x, and we're going to be adding a negative 4x plus 5, which is going to give us an answer of negative 2x plus 5. Next, we're subtracting the two functions. So right now I have 2x, and I'm subtracting, and notice I'm putting this in parentheses, a negative 4x plus 5, because I'm subtracting all of that. So if I'm subtracting all of that, I'm really distributing a negative 1. So this is really 2x plus 4x minus 5, which will give us an answer of 6x minus 5. Question 7. Solve for x. Here we want to make sure that our bases of our exponentials are the same. So I can rewrite this side as 6 squared, but I'll raise all that to the negative x power. And this is going to equal 6x to the 2x minus 1. I'll have this extra x in here. This x doesn't belong here. So now, since the bases are the same, the exponents are going to equal each other. So the left side is still 2x minus 1 equals 2 times negative x is negative 2x. So now all I have to do is get all the x's to one side. So I'm going to subtract 2x on both sides. And we're left with -1 equaling a -4x. To get x by itself, we're going to divide by -4. And x in this case is going to equal 1/4. Question 8, find the sixth term of the following sequence. So here, we need to find out first off, how are you going from one term to the next? Well, here I know I'm just multiplying by 2 and then multiplying this by 2. So I have a common ratio of 2. So we're going to use the formula a subscript n equals our first term times the common ratio raised to the n minus 1 power. So we want to find the sixth term when the first term is 5, the common ratio is 2, and we're going to find the sixth power, so 6 minus 1. So this is going to give us the sixth term. It's going to give us 160. Because 2 to the fifth power would give us 32, and then 32 times 5 gives us 160. Question 9. Mr. Fernandez deposits $60,000 in an account that pays 2.5% annual interest compounded quarterly. What will be the balance after 20 years? Round to the nearest cent. So this is compound interest. So we're going to use the formula A equals P times 1 plus the rate divided by n raised to the nt power, with r being the interest rate, n being the number of times it's being compounded, and t the time in years. So our P, the initial amount is $60,000. So we have 60,000 times 1 plus the rate as a decimal. So I have to divide this by 100, so move it 2 places to the right. So this would be 0.025. Divided by quarterly means 4 times, raised to the 4 times 20 years. So we'll grab our calculator. So we got 60,000 times, and we'll do parentheses, it would be 1 plus, we have 0.025, divide that by 4, end parentheses, I'm going to raise that to 4 times 20 is 80. That gives us $98,769, and to the nearest cent, it would be 47 cents. So 98,769. And 47 cents, just verify that. So $98,769.49. Question 10, determine whether each function represents exponential growth or exponential decay. Now this is all based on the base of the exponential. So if the base is bigger than 1, then it's a growth. If it's a fraction between 0 and 1, then it would be a decay. So since here it's bigger than 1, this is a growth. Our base here, or our common ratio, would be less than 1. This is a decay. And 4/3 is bigger than 1. This would be a growth. Question 11. Simplify here. So we're just going to be using our rules of exponents. So I have to raise everything to the 4th power. So that means 6 to the 4th power, and then times e to the 4 times x power. So on our calculators, we're going to have 6 raised to the 4th power, which will give us 1,296, times base e raised to the 4x power. So this would be our answer, we're just going to keep base E there. Question 12. Asa is investing $2,000 in an account that grows at a 0.7% annual interest compounded continuously. What would his account balance be after 3 years? So this is compounded continuously, so we're using base E. So this would be A equals, and we're going to use the PERT formula. So P times base E raised to the RT power. So we have A, account balance, principal amount is $2,000 times base E raised to the rate as a decimal. So move it 2 places. So this would be 0.007 times the number of years, which would be 3. So we'll grab our calculators again. So we have 2,000 and base E, so second natural log button, and then we'll have 0.007. We're going to multiply that by 3, end parentheses. That gives us $2,042.44. Question 13. The pH of a substance can be represented by the equation y equals log base 10 of 1 over H positive, where H positive is the number of hydrogen ions. Find the H plus, or the hydrogen ions value, if the pH of apple juice is 3. Round your answer to the nearest 10,000th. So the Y in this case is the pH value, so I'm going to put 3 in for Y. And I'm going to switch the whole equation around. So first off, to rewrite this, I'm going to break this apart as this would be log base 10 of 1 minus, it's minus because I'm dividing right here, log base 10 of H positive, and this is going to equal the pH value of 3. Now here, if I think of what do I raise 10 to get me an exponent, or to give me an answer of 1. So I'm just treating this like put this as an exponential. 10 to what power gives me 1? 10 to the power of 0 is 1. So this is 0 minus log base 10 of H positive equals 3. So now I need to get rid of this negative here. So to get rid of this negative, I'm just going to divide by a negative 1. And now I'm left with log base 10 of H positive equals a negative 3. And now I'm going to put this as an exponential. So base 10 raised to the negative 1/3 power, or negative 3 power, equals H positive, which this is going to equal, now if I do 10 to the negative 3rd power, that's going to give us a decimal. That would be 0.001. Now that gives us an exact decimal, so we're just going to keep that. So we have an answer of 0.001, which isn't to the nearest 10,000th. That's actually to the 1,000th place, but we can't go any further. So our answer would be 0.001. Next, 14, solve the equation. Check for extraneous solutions. Just a reminder, extraneous solutions mean you will get a solution, but if you put it back in, it won't make sense. So when the bases of logarithms are the same, everything else is going to equal each other. So 2x minus 20 is going to equal 6x. Now I can change this to a polynomial or a trinomial. So I'm going to subtract 6x on both sides, and I'm left with 2x minus 6x minus 20 equaling 0. And I'm going to factor out, I can factor out a 2 on both sides, and I'm left with x. This is an x squared. So I have x squared minus 3x minus 10 equaling 0. Now I can factor this. I gotta think, what do I multiply to get negative 10, but add them together gives me negative 3. That would be a negative 5 and a positive 2. And if I make each of these equal to 0, here x is going to equal 5, and here x is going to equal a negative 2. Now if I put them back into the original equation, I cannot find a logarithm of a negative number. So if I put a negative 2 in for x over here, 6 times negative 2 is negative 12. I can't find a logarithm of a negative number. Therefore, negative 2 is extraneous. The only solution would be x equaling 5. Question 15. Graph the function and then find the key features. So now for this one, I would just rewrite this. 6 to what power equals x? So 6 to the y power equals x. I'm just going to do a quick table here. And I'm going to use the numbers negative 1, 0, and 1. So 6 raised to the negative first power is going to give us, actually I have that, I put them in the wrong spot here. So if I put this as negative 1, 0, and 1. So if I put 6 to the negative first power, that's 1/6. 6 to the 0 power is 1. And 6 to the first power is 6. Now I can just plot those on here. So 1/6 and negative 1, that would be roughly here. Then we got 1, 0. And then we got 6, 1. So this equation, or the graph would look something like that. So now let's find the domain. The domain here, it never goes past the y-axis. So the domain would be x such that x is greater than 0. So it never equals 0. I can't put an x value as a negative, so it's just going to be greater than 0. The range, it keeps going up and down, so this one be y such that y is all real, or an element of real. The x-intercept, we have the x-intercept at 1, 0. The asymptote line would be y equaling 0, or x equaling 0, or you can say it's the y-axis. And then the end behavior. As x approaches negative infinity, y approaches 0. And as x approaches positive infinity, y approaches positive infinity. Question 16. Write each equation in exponential form. So here we have base 3 raised to the 5th power is going to equal 243. Next, we're going to write each equation in logarithmic form. So we have log base 27 of 9 is equal to 2/3. Question 17, we're going to use log base 2 of 3 equaling about 1.5850 and log base 2 of 5 equaling about 2.3219 to approximate the value of the expressions below. So I need to break down 30 using 3 and 5. Well, I know that this could be broken down as 2 times 3 times 5. So I'm going to have log base 2 of 2 plus log base 2 of 3 plus log base 2 of 5. Now I'm adding it because if I expand a logarithm, I expand it with addition. Now log base 2 of 2 is just 1, plus log base 2 of 3 is 1.5850, plus log base 2 of 5 is 2.3219. So now if we grab our calculators, we're just going to add all those up. So we got 1 plus 1.5850 plus 2.3219. That's going to give us 4.9069. And then the next one, since this is written as a division problem, to expand it, that's going to be written as a subtraction problem. So this will be log base 2 of 3 minus log base 2 of 5, which that's going to tell us we're going to have log base 2 of 3 is 1.5850 minus log base 2 of 5 is 2.3219. Grab our calculators again. So we have 1.5850, and we're going to subtract 2.3219. That gives us an answer of a negative 0.7369. Question 18. Write the expression as a single logarithm. So when we have a number out in front of a log, we put that as an exponent. So right now we have natural log of 4 cubed plus the natural log of 3 cubed. Now 4 cubed would give us 64, and 3 cubed would give us 27. So if we put this all under 1, natural log, this would be natural log of 64 times 27, which will give us the natural log of 1,728. Next, do the same thing. Put the 8 on this x, the 4 on the 5. Since it's subtraction, we're writing as a division problem. So this would be natural log of x to the 8th divided by the natural log of 5 to the 4th power. So if I put this all under 1, it'd be natural log of x to the 8th over 5 to the 4th power is 625. And this would be our expression written as 1 natural log. Next, simplify. Here we're just going to multiply straight across. This is going to give us 36x to the 3rd y divided by 72xy to the 4th. And then simplify that. 36 is half of 2, so right now we're going to 36 is half of 72, so I'm going to have 2 in the denominator. X cubed divided by x is x squared, but it stays as a positive on top. Y divided by y to the 4th is y cubed. That stays on the bottom. So our final answer would be x squared divided by 2y cubed. Question 20. Here we're dividing polynomials. So the first thing I'm going to do is I'm going to factor everything. So in the numerator of the first one, I have, think, what do I multiply to get 50? But Adam gives you 15, so that's x plus 10 times x plus 5. The denominator is x plus 2. And then I'm going to multiply by the reciprocal of this one, which that makes x plus 2 on the top. And on the bottom, this is going to be x plus a number times x plus a number, and I got to think, what do I multiply to get 200? But add them together gives me 30. So this should be 20 and 10, because 20 times 10 is 200. 20 plus 10 gives you 30. Now the x plus 2's divide out. I have an x plus 10 here and x plus 10. That leaves me with an answer of x plus 5 divided by x plus 20. Next, we're simplifying here. When we're subtracting, treat these like fractions. I need common denominators. Common denominator of both is 18. So I have 18 and then a yz. So this one I need a 2z. So multiply the top and bottom by 2z. That gives me 4xz minus, over here I multiply by 3y. That gives us 21y squared. So this would be my answer for that subtraction problem. There is no common factor amongst all three terms. Moving on to question 22. Here, there's a couple ways of doing this one. I feel like the quickest way is to multiply all four fractions by the least common denominator. The common denominators of all of them are y, x, 2, and x, so that'll be 2xy. So I'm going to multiply every part by 2xy. And what I have left is my answer. So here I can divide a y out here. That leaves me with 2x squared. Over here, an x divides out, and I'm left with 4y divided by the 2's divide out, and I'm left with x squared y. Here the x's divide out, minus 2y squared. Now if I look at all four parts, there's nothing in common, so this would be my simplified answer. Question 23, if y varies inversely as x, and x equals -5 when y is -1.1, find y when x is 2. So varies inversely. This is all based on y equaling our constant divided by our x. Now if I want to make this get the constant by itself, I multiply by x on both sides, and that's what I'm going to have. I'm going to have x1 y1 equaling the constant, or x2 times y2. So I have two inverse operations here. So here, if x is -5, when y is -1.1, find out what y is when x is 2. So -5 times -1.1 is 5.5, equaling to y. If I divide everything by 2, grab our calculator again. We have 5.5, we're going to divide that by 2. That gives us 2.75. So y is going to equal 2.75. 24. Suppose y varies directly as x and varies inversely as z. Find x when y is 6 and z is 28. If x is 7, when y is -49 and z is 3. So here I have the formula that we're going to be using. So my y, so we need to find x1 when y1 and z1 are here. These are 2's. So I have 28, and our y is 6, divided by x when our y is, or our z is 3, our y is -49, and our x is 7. So for this one, all I'm going to do is I'm going to do everything on the calculator very quickly. So I have 28 times 6 times 7. And then that one I'm going to divide everything by, and I have parentheses 3 times a -49. That's Let me go back to what I had here. I got to use a negative symbol here. Gives us a -8. Question 25. A high school has a total of 1,800 students with 475 seniors. Of the 1,800 students, 1,625 are taking a math class, 350 of which are seniors. If a student is chosen at random, what is the probability that he or she is taking a math class given that the student is a senior? So we know that they are a senior, and there are 475 seniors in the school. Now, out of those 475, we want to make sure that they are a math student, and there are 350 seniors who are taking math. So I need to simplify 350. So 350 divided by 475. And put that as a fraction. That's going to give us 14/19. Or if you were to put this as a percentage, I would put it as 73.7%. Question 27. A date is chosen at random from the calendar. Determine whether the events are mutually exclusive or not mutually exclusive. So mutually exclusive means they cannot happen at the same time. Not mutually exclusive means they can happen at the same time. So choosing a date in the first or second week of January. Well, if you choose a date in the first week, it can't be in the second week. So this would be mutually exclusive. Choosing a Monday or a Friday. So if I choose a Monday, it can't be a Friday, so that's mutually exclusive. Choosing a Sunday or a date in June. Well, I can choose a Sunday, or I choose a date in June, but it can also be a Sunday as well. So this is not mutually exclusive because they can happen at the same time. And the last part, choosing the 15th day of a month, and this should be or choosing the first Tuesday of a month. Well, if you choose the first Tuesday of a month, that's going to be within the first 7 days. That can't be the 15th day of the month. So no, this can't happen at the same time. So this is mutually exclusive. Question 27. The numbers 0 through 7 are used to create a 2-digit PIN number. If the numbers cannot be repeated, what is the probability that the PIN number is 17? So the numbers 0 through 7, that would be 8 total digits. So there's only one opportunity to get 17, and you know it's a 2-digit number and they cannot be repeated. So that means I can use 8 digits here. That leaves me with 7 over here because they cannot be repeated. So this would be 1 over 56. Question 28. There is a bag of 5 black and 4 yellow marbles. 2 marbles are selected without replacement. What is the probability that both marbles selected are yellow? So we have a total of 9 marbles. Out of the 9, there are 4 yellow. So the first pick, you have 4 out of 9 to get a yellow. But it says that you're not replacing it after you take one out. That means there are 8 left over. And out of the 8 there are only 3 that are left over that are red, or that are yellow. So if I multiply, that gives me 12 over 72. I can divide these by 12 twelfths. And this is going to give us 1 over 6. You have 1 out of 6 chances of getting those 2 yellows. Question 29. If Evan's senior class of 240 students, 85% are planning to attend college after graduation, what is the probability that a senior chosen at random is not planning to attend college after graduation? Well, if you have 100% of the class and 85% are attending college, that leaves you with 15% that are not attending graduation or attending college. Question 30. Tom got a new bicycle lock that has 4 number combination. each number in the combination is from 0 to 5, how many combinations are possible if there are no restrictions on the number of times each number is used? Well, I can only have one of that combination. It's 4 digits, and we are using 6 digits, so that's 6, 6, 6, 6. And since we're only looking at for how many combinations, not probability, I'm not going to put the 1 over there. So now all I have to do is, on my calculator, 6 to the 4th power, that's going to give us a total of 1,296 possible combinations. Now the other one, if each number can be used only once. So I have a 4-digit combination. Each digit can only be used once. So that would be 6 times 5 times 4 times 3. So that's 30 times 12, and 30 times 12 would give us 360. So you would have 360 combinations possible. Question 31, use a matrix to organize the data. So here, right here would be our matrix. Now what are the dimensions? I have 4 rows, which is my drink type, and I have 3 columns, which is my size. Letter C, what is the value of A42 and what does that represent? So 4 tells me I got to go to row 4. 2 tells me I got to go to the second column, which would be $1.10. And that represents a medium coffee. So the cost of a medium coffee. Question 32. Find the following. Here we're just going to multiply by the scalar and then add our answers. So this would be 0, 6, 6, -4 to 12. And then we're going to add this matrix. So we get an answer of 0 plus 1 is 1, 6 plus 6 is 12. 6 plus a -1 is 5. -4 plus 2 is -2. 2 plus -1 is, or -3 is -1. And 12 plus 1 is 13. Next, find the determinant. So I'm going to take these two. 3 times 4 is 12, minus, going the opposite direction, a positive 12 equals 0. And our final question, find G of H if G equals this matrix and H equals this matrix. So again, this is a 2 by 2 and this is a 2 by 2. Since these middle two are the same, our answer is going to be a 2 by 2. So this is in row 1, column 1. So I have 1 times 5, and I'm going to be adding 3 times 9, so 5 plus 27. 5 plus 27 is 32. This is row 1, column 2. So this will be 1 times -2 plus 3 times 4. So we have -2 plus 12, which will give us 10. This one is in row 2, column 1. So we have 8 times 5 plus -4 times 9. 40 minus 36 is 4. And our last one here is row 2, column 2. We have 8 times -2 plus -4 times 4. -16 plus -16 is -32. So that is a quick review on how you can what you can use to review for the second semester test covering module 6 through 11.